Good afternoon. Welcome to the webinar. So before we start, I'll introduce myself first. I'm Paulina. I'm the Customer Experience Manager at Amsterdam Standard, and my guest today is Albert from Hostersi.
Hi, everyone.
Albert is a... Hello. Hi. Albert is a... I'll give you a short intro. Is a senior sales manager at Hostersi with more than 15 years of professional experience in. He started working as a support engineer and went through QA, project and product manager before settling finally on sales with focus on cloud-based solutions. Okay, moving on, I'll show you the agenda because for today we will cover 5 ways to prevent overspending on cloud, and Albert will address continuous monitoring, usage analysis and tagging, right-sizing resources, reserved instances, leveraging serverless, and then we move to the QA section. So hello, Albert, officially glad to have you here today.
Okay, thank you, Paulina. Hi, everyone. As Paulina mentioned, my name is Albert, and I'm here today because one of my functions as an account and sales manager is providing customers with insight into cloud cost structure and discussing ways in which it can be optimized. So today I'm going to share with you a few tips on how I approach this problem in my customer projects, and hopefully you will be able to do it in your projects as well.
Thank you for that. So we'll jump right into the first of the 5 tips. The first one is monitoring cost, which can sound pretty straightforward, but we'll let you elaborate on this.
Yes, so our goal when optimizing SaaS costs is first and foremost to know where the money is going. So this can be achieved through continuous monitoring of your cloud usage. And for this, I recommend using a dedicated monitoring tool to gain insights into your resource consumption and to identify areas where it is potentially maybe wasted or maybe things are not going the way they should. So for cloud-based solutions, each of the big 3 vendors provides its own tool that is available at the management console level. So for AWS, you have the AWS Cost Explorer, which you can see on my screen right now. For Azure, we've got the Azure Cost Management, and for Google, we've got the Google Cloud Cost Management. And as you may have noticed, the different tools look quite similar and basically offer the same level of insight into each specific cloud.
Mm-hmm. So this is the first step. So pretty much just having something to monitor your costs, and you recommend using those native tools.
This is where I always start with my customers, because you can gain quite a lot of information from that. And once we have this in place, in order to get the best insight into this usage, I also recommend implementing cost allocation and resource tagging to attribute the expenses accurately. This allows you to identify which teams or projects are driving the cost. And again, here you can utilize the cloud provided features that are built into the monitoring tools available. So successful cost allocation strategy should incorporate the following things. So first and foremost, clear objectives. So you have to decide if you want to allocate costs by department, project, environment, product, or any other criteria you might have. And also understand what insights you want to gain from each of these perspectives. Then you have tagging strategies. So you have to develop standards and guidelines so that everyone in the team understands how you should tag resources, which resources should be tagged, and this should be unified on a company level so that between different projects and different teams, there is always one common language used. And make sure that all your teams are aware of these tagging requirements, and also review frequently whenever resources are updated, changed, added, removed, whatever. Next, we have resource grouping. So it is always good to group resources logically based on your tagging. So, for example, create resource groups for specific departments, projects, or cost centers. This will allow you to aggregate costs at different levels of granularity, and such as the department level or the project level, and this will be very clearly visible in your cost monitoring tools. After that comes the regular review. So you should always not only review the tags and whether they are properly applied, but also review the insights you get from the numbers you are seeing, and discuss this with your stakeholders, with the team members, and so on, so that you can start analyzing spending patterns and identify cost savings opportunities. Once we have that in place, we can move on to analyzing the usage patterns, where we can decide whether we are allocating resources efficiently, and also see where they are potentially wasted. And again, here I recommend using an automated tool which will do the job basically for you, and these tools are also available within each cloud provider's console. So the native apps for Amazon is Amazon CloudWatch, for Azure is Azure Monitor, and for Google it's called Cloud Monitoring. Once you use these tools, you can also supplement them with additional third-party solutions. And here, my recommendation would be looking into Datadog, which provides real-time visibility into cloud usage patterns with some nice customizable dashboards and alerting. Then we have New Relic, which is an application performance monitoring tool and observability platform. And it helps you to understand how your apps use resources and detect performance bottlenecks. We have also Prometheus, which is a toolkit to collect metrics and help analyze resource usage patterns in containers, so Kubernetes and similar. Then we also have Elk Stacks. That means Elasticsearch, Logstash, and Kibana, which are very popular open source solutions for log management and analytics. Okay,
so you mentioned 3 native apps for usage pattern analysis and 4 third-party. And is there like an advice you can give how to choose one of these?
Well, the hard thing is that there really is no one-fits-all approach, as each of these tools offers some unique approach to how it collects and displays data. But in general, I always recommend starting with the native tools first. And once we have got a good strategy for collecting data, we know what is happening, we can then start using a few of the solutions mentioned here, so Datadog, New Relic, Prometheus, and Elk Stack. The decision would be, for me, would be finding a solution that is either very easy to implement for you or gives you the best insight into your infrastructure with the least work. The 4 mentioned here are the most popular ones. Out of these 4, I think Datadog and New Relic are the ones that most customers of mine get the most use from.
Clear. Okay, thank you. Moving on to the third tip, because first was monitor, then usage analysis. The third tip was right-sizing. And can you tell us what is that in the context of cloud saving?
Yes, of course. So right-sizing basically means matching your resources to actual needs. And the best approach for me to go about it consists of 5, I would say, steps to be able to decide what's the right size for our resources. So first, as I already mentioned, gather usage data. So we collect the detailed usage data and want to understand how resources are being utilized. And this is why monitoring and data collection is so important. Then we have to identify over-provisioned resources, but also underutilized resources. So we can see using the graphs displayed in the different tools which servers are running on full capacity all the time, which servers are not running at to capacity. And based on that, we can start determining, so the analyze and test phase, which of the most critical resources have to be changed. Once we have decided that, we have to implement these adjustments. So we need to make resource changes in production. I recommend to do them incrementally. So no, not everything at once, but really going step by step and constantly monitoring the impact of the performance. And whenever possible, try to automate so that you can have a flexible system moving forward. And the fifth step would be, again, to continuously monitor and optimize. So once we right size our resource, we cannot be sure that it will stay right sized all the time, because there may be some changing workloads. We may have may launch a new campaign which brings us thousands of new users, and this may impact what we've done previously in right sizing. So it's always very, very important to keep track of what is happening in our systems and adjust to the changes accordingly.
All right, so this is something to be observed continuously and adjusted, yeah?
Yeah, that's correct. So moving on, another tip I have are reserved instances. And reserved instances are basically the easiest way to introduce cost saving for predictable workloads. In general, the reservation types vary from cloud provider to cloud provider in duration. So we typically have reservations for 1 to 3 years. And obviously, the longer the reservation, the bigger the discount you get. Flexibility to change the instance. This is very important because you may not be allowed, once you reserve some capacity, to change its type, or you will be limited to specific instance types. And I will touch upon briefly why that matters in just a second. And then the difference may be in services that are eligible for reserving. So all providers allow to reserve compute instances, so basically servers. But if you want to reserve storage, database capacity, or other specific services, there may be some limited options based on which provider you are using. So if you plan to reserve, it's always good to see what the options are even before you go to a specific cloud. The discounts that you can achieve through reservations can reach up to 70% compared to on-demand costs. So there is quite a lot of cost savings to be made. And one thing worth mentioning is coming from my own experience and related to this flexibility of changing instance types. In many cases, if you go for the longest reservation periods, you may lose the ability to change your composition of servers. And this matters because each year the cloud vendors release new services and also update their hardware, which you may not be able to take advantage of if you reserved a different type of capacity upfront. So, and this way you may miss out on performance and optimization opportunities that can be also effective cost-cutting measures in of itself. So this is why with most of my customers, we always recommend them to start reserving for 1 year and looking into 3-year reservations only for very specific workloads where we know that there will be like no change, or they are being grandfathered to not really be used, and so on. So this is where the longer reservation would come into play. However, my first tip would go to start with 1 year and working from that, just because there is very, very many things can change in the meantime.
So it's like it gives you the ability to possibly get bigger discounts, but you have to do it carefully.
Yep, that's correct. As I mentioned, the discounts you get may not be as significant as what you can get by gaining performance, for example, because this may allow you to serve more customers without raising the cost. So there is always this cost benefit to everything, and it is really good to consider a few factors before going all in.
Yeah. That's interesting. Yeah. So, and the fifth hack, leveraging serverless. Can you explain what that would be?
Yes. So the final advice is also the most technically involved, I would say, just because you need to prepare to be able to use serverless. So basically, what serverless instances or serverless services are, these services automatically scale with usage, so you don't need to manually manage any resources and only use computing capacity when invoked. So basically, they allow you to execute your application code on the cloud rather than having to deploy an application to a server and then running it. And each of the cloud vendors has its own version of a serverless compute. For AWS, it's called Lambda. For Azure and Google, it's called simply Functions. One caveat with this serverless approach is that you need to develop for it. So you need to allow it to be executed directly in the cloud. There are some limitations like the states of each application. There are actually even more limitations, but I think I will not go into them in the interest of time right now. However, what you just need to keep in mind that if you are developing a new solution, it is worth considering breaking it up into smaller functions, which could then be used through serverless in specific use cases. A few examples I can give is backends for mobile and web apps, where serverless can be used to handle smaller tasks such as user authentication, some data processing, or notifications. And here, instead of managing and scaling traditional servers which would run all these applications on them, dedicated functions are invoked as needed. So, for example, a user wants to register and needs to be authenticated. We just execute a small part of the code which does the authentication and allows the user to log on, and then we just and then we don't need this part of the application anymore. So it is closed, turned off. You don't have to pay for anything else. So this is very helpful if you are having applications with varying usage patterns, because you don't have to prepare for anything. You just allow the application to run when it's needed. Another thing where serverless is also very helpful is content delivery and image processing. And here, serverless functions can be used for on-the-fly image processing and optimization, like resizing or video encoding. And this makes it easier to manage and store static content like pictures, movies, and you are able to deliver it in different sizes for different devices using only one source file. So basically what happens if a user logs on to a mobile phone and wants to see the list of our products with pictures, the backend will invoke a function which converts the one big image into smaller image sizes suitable for the mobile app. And if you log on a PC, you will get image sizes that are suitable for a PC, basically. And the key cost benefits of using this serverless approach are pay as you go. So as mentioned, you only pay for the execution time and resources used by the functions when they are invoked. And if the user activity is low, there are no idle servers which are running, which you have to pay for. Scalability, again, this is built into the serverless platforms. They automatically scale to accommodate any changes in user traffic. So this ensures that your application can handle peak loads without the need of provisioning dedicated resources to be able to do so. And it also comes with cost predictability. So with serverless, you know how much it costs to invoke a function. And you can then easily extrapolate it onto the numbers of users you are serving or you want to serve. And this way, you can plan better how to use up your budget. And the last thing and that is definitely a good cost saving, is reduced infrastructure management cost, because you eliminate the need for provisioning servers, patching, maintenance, and so on. You just simply write your code, place it in a dedicated area, and let it run when needed.
Perfect. So that's the conclusion of 5 tips. But I'm wondering, Albert, if you've ever counted how much you can actually save using those tips. Is there like a percentage you can?
Well, I must be honest, and reaching 70% with reservation is very rarely the case. However, depending on what the workloads are, what you are using, and which of the specific things you can implement, the savings can be everything from 10% to 50%, even with specific cases. Like, for example, we've been able to 50% is something that we've been easily able to achieve using the serverless functions for scaling backends. So what I mentioned with pictures and so on, and the cost cutting or cost saving comes from lower cost of providing the data. So I'm not sure if you are aware, you have to pay for the traffic that goes out of the cloud. So basically, whenever you are serving something from the cloud, there is cost associated. And by using serverless functions and also additional content delivery network, you are very easily able to cut down the cost of this traffic by 50%. In some cases, even more, depending on what is happening in your application. So I would say definitely 10-50% are things that are doable, but not along the board. It really depends on what the customer needs or what the specific use case is.
Yeah, probably the setup that they have currently. Okay, we have a question. I don't know, Albert, if you see it.
Hang on, I'll open the chat. So just as a conclusion, I hope that I have shown at least a few insights, and I hope that following these practices I show you will help you to do a little bit more with the cloud. And now, coming back to the questions, can you give some examples of how cooperation with SaaS looks like with you? From what cloud bill is it worth to work with server experts like you? Well, we don't have like a minimum of cloud bills where people start working with us. However, what we are looking for is, if you have got, as I mentioned, big amounts of data going out of the cloud, or you have the need or think you have the need for using very powerful, very expensive machines in the cloud. These are some areas where we definitely can help, because monitoring is one thing and optimization is quite another beast in and of itself. So one thing is knowing where you are spending, and the other is how to not overspend. Okay, and another question: what cloud provider, AWS, Azure, GCP, I recommend? I really cannot answer this question, or maybe I can. So I would not. It depends on what you are trying to do. What we see from our customers, AWS is the most commonly used one, mainly because I think it has done its share work with developers. So many developers know AWS and want to use it. Azure right now is gaining up to them. And whenever you have workloads which are relying on Microsoft technologies, Azure is the simplest and fastest way to go. So it also boils down somewhat to preference, but also to the specifics of your application. GCP right now is gaining a lot of traction, and it's mainly right now used for, or the way I see it being used is for containers. So whenever you are working with containers, I see the trend with developers is to go rather with Google than with other providers. But again, there is no clear one cloud provider. I would say is the de facto default one you should go with.
Okay, do we have any other questions from anyone? Okay, we are past 25 minutes, so I think we can wrap up at this. Thank you, Albert, so much for joining us here. Albert's credentials, website for Hostersi, if anyone is interested to see that. So thank you for joining and have a good day.
Yeah, also from my end, thank you very much. And again, I hope that I have been able to bring a little bit knowledge to you, and also wish you a very, very nice day. And hopefully we'll be able to connect through LinkedIn or any other way. Yeah. And also, Paulina, thank you for having me.
Thank you. See ya.
See you. Bye-bye.